Facilities that make this program possible are provided by the City of Highland Park. Programs are produced independently by members of the community. The City of Highland Park is not affiliated with the following program or the producers of public access programming and is not responsible for the content. The following program does not reflect the opinions of the City of Highland Park.
Hi, welcome to another edition of What's This Show For, FOR, Friends of Ron. I'm your host, Ron Levitsky. When I was a kid, I really enjoyed the old Flash Gordon movie serials that were shown on TV. And I always identified with Flash Gordon fighting all those crazy aliens and monsters. But recently I read that a physicist who's almost exactly my age, Michio Kaku, identified, he loved the show too, but he identified with Dr. Zarkov. Because he said it was Dr. Zarkov who actually got the space vehicle going to take Flash Gordon to the planet Mongo. That's a good way of looking at things, that our heroes can be different kinds of people, and those who think about how we get to launch objects into space are truly heroic. We see this in the movie Hidden Figures, for example. Well, today we have someone who's made a hobby out of rocketry, and it's a fascinating hobby. He's going to share some of that with us today. So I want to welcome my guest, Kenn Blade.
Thank you, Ron.
Kenn, welcome. I'm glad you're here. I know that you're from Massachusetts.
Correct.
And full disclosure, you're my brother-in-law.
Yes. Yeah.
So you're in the real cold weather, but I'm glad you're here. And we took the opportunity of your visit to have you speak about something you've told me about many times. I've been fascinated with model rocketry. So let's start off by just tell me a little bit about yourself, and especially what made you as a kid become interested in model rockets?
Sure. Well, I grew up during the 60s, during the space race, and was always fascinated by the mechanical equipment of rocketry and farming and all sorts of other mechanical things I could watch on television. But rocketry, of course, with the fire and the smoke and the noise and the adventure was definitely a big draw. In my junior high school years, 7th grade, my local school had a model rocket club start up. And that was my first exposure to model rocketry. We were, yeah.
No. So you got involved as a kid.
Yes, yeah.
And what's interesting is that I'm sure a lot of kids sort of gave it up, but you went back to it as an adult.
Well, yeah, I stayed with it for a little while. My friends and I that were in the club continued it over the summer and maybe for a couple of years afterwards, but other interests drew us away, and about 15 years later I got back into it for a little while, but I was out in Western New York on my own, no clubs or anything, and I had some fun, but it faded away as well. More recently, about 1999, I found out that the local club in Massachusetts actually flew in the town that I live in on a city park, or actually a hayfield that is part of the city park system. And I went over to see what it was all about, and I've been going back ever since.
Interesting. And when we talked, I looked up your national organization online and found that there are actually quite a few clubs in Illinois.
Absolutely.
As well, which I didn't know about. Now, we've got a lot to cover, but I think of people in model rocketry as being male, who are very science and math oriented. Is that fair, or is that changing?
It probably describes a very good percentage of the people that are involved in model rocketry and high power rocketry these days, but we have people from all walks of life. We have a number of women that are becoming more involved these days, and of course children. Some children come along, more of an excuse for the parents, I think, to do the hobby than the kids. Some of the kids get interested in other things again, but the parents continue to show up to the launches.
Okay. Well, let's go a little bit deeper. So we've been using the term model rocketry, model rockets. What is that? What is a model rocket?
Okay, a model rocket is by a federal code, and I don't have the exact numbers at the tip of my tongue, but it can't weigh more than 1.5 kilograms. It can only contain a certain amount of propellant by weight, and a certain amount of total impulse, total engine energy, limits you to the upper level of what model rocketry can be. Beyond that, there's high power rocketry, there's amateur rocketry, there's any number of other things which are regulated by other parts of the federal codes.
But ultimately what you want to do, I guess, is to shoot your rocket off successfully and then recover it.
Correct, yeah.
Okay,
yeah.
okay.
Yeah.
Let's then talk about kind of going to a launch. You know, how is the field prepared? What preparations? Because you're in a leadership role, so you have to oversee a lot of this all the time.
Right.
And we're going to see a couple of slides in a moment, but what are some of the preparations you have to do?
Yeah, we have the club that I belong to has a supply of ground support equipment that club members will come beforehand, before the scheduled launch. Somebody will haul the trailer from wherever they have it stored or at their own property, wherever. Bring it there, we'll unload the equipment we need from the trailer, and volunteers will start setting up the launch range. This involves driving stakes into the ground, putting adjustable pad heads onto those stakes, launch rods, laying out electrical wires, and all the other ground support equipment.
Okay, let's take a look. Let's start out with kind of the logo, which you have on your shirt, but we've got a interesting picture to start us off. So we can get the first slide up, please.
Yeah.
And you get the Minuteman. Okay, so there's a real Minuteman.
Yep.
This
was at a winter carnival that we were invited to do some demonstration rocket flying at, and there was another group there of Revolutionary War reenactors. And every now and then they had a nice little campfire going, a little encampment. Every now and then they would fire off their muskets, which would draw a lot of attention. But we were more consistently firing off our rockets, and this young fellow was interested. He came over, and we couldn't help but notice the resemblance between him and my club's logo in Massachusetts.
That's great.
So
let's go to the next one, please. Okay, so here we've got, I guess, the setting up.
Yeah, this is a view of the launch area. The flag is at the center, and wires radiate out to various pads, 11 different pads. And this shows the launch control box on one table, a fellow working at the safety check table, and a board that we use to assign the different rockets to different pads to know what's being launched from where.
So do rockets ever get shot off simultaneously?
We can do drag races with our equipment.
All right, we'll talk about that later.
Yeah.
All right, let's go to the next slide, which I think is another view of the setup.
Right, now this is a little more activity going on. People are lined up to go to the safety check table to get their pad assignment. Once they're assigned a pad, they go out to the pad to load the rocket onto the launch rod and hook up the electrical clips that will eventually fire the engine.
Okay, and we've got a really cool shot next, which is a different view. So if we can have the next slide, please.
And this is a view from a camera that was on board one of the rockets.
Okay.
Looking back down at the launch area and some of the preparation area that the flyers are using. You can see in the center is a kind of there's a smoky patch right in the center of the picture, and a little bit to the left of that is the center of the launch pad ring. It's difficult to see the actual ring, maybe some of the wires on the ground.
I can see the trailing off. So
Yeah.
Okay, well let's come back then, and since we got a nice taste for this, you brought a model rocket, and if you could explain, we use the term rocket, I know there are different kinds from simple to more complex, so if you can give us just a basic view of what a rocket is, what's in it,
Sure.
And then we can talk about some of the different ones.
Sure. Most all of the rockets involve a design very similar to this. There's a body tube, a nose cone, and some set of fins, 3 or 4 fins, more or less depending on the actual design. On the interior, we have a parachute that would be used for recovering the rocket safely, and to start the process of preparing the rocket before you come up to safety check, you would take some flame retardant recovery wadding that is sold along with the motors that fly the rocket, and loosely crumple that up and stuff it into the tube. This creates a barrier between the hot exhaust gases of the motor and the typically plastic or nylon parachute. You would then fold the parachute up, roll it neatly in the shroud lines, load that into the rocket, and then load the rest of this elastic shock cord that provides a little resistance to things being torn apart. It gives the nose cone coming off a chance to gently decelerate, but then after that's loaded in this particular case, you would load a motor into this tube. And this particular design, the fin can acts as a capture for that motor. You would put an electronic or an electric ignition system, it's called a starter, that goes into the motor, held in with a little plastic plug or a little wad of paper. And the two wires that come out from that eventually get hooked up to electrical clips that complete the circuit that would fire this.
Okay.
You'd bring this up to the safety check table, that line that we saw in the previous shot. They would check it over. If they aren't familiar with you, they might ask you if you've loaded all of the recovery wadding, if you've done everything correctly. And they'll assign you to a pad. You'll take it out, slide these launch lugs down over a rod so the rocket is standing on the pad. You'd hook up the electrical wires, making sure that the metal parts aren't touching each other, creating a short circuit, and then step away to the observation area. For rockets of this size with the motors they use, it has to be at least 15 feet away, and a slightly larger motor would require a safe distance of 30 feet away.
Okay, so if we could go from this to our next slide, and we'll see a couple of very different rockets, and then a motor. You can talk more about the motors.
Sure.
So the next slide should be very similar to what you see on the table. We can get that up. It's,
yeah.
All right, so there.
This is the same crayon model as this rocket is. It's just a different color, but it's showing the rocket lifting off from the pad. The launch rod that it's put down over is 3 to 4 feet long, and this gives the rocket a chance to fly straight and true until it gets up enough speed where the aerodynamic forces over the fins can stabilize the rocket and keep the flight straight.
Okay, so this is a very simple and it's a very inexpensive rocket.
Relatively inexpensive rocket.
Okay,
yes.
let's go to the next one, which seems far more complex.
Right. Now this kit is this is the Acme Spitfire by the Fliss Kits company, the silver one that's launching off. You can see the rod that it's launching from. And it's a more complex kit to build, but it looks very strange. It actually zigzags back and forth. The body does, and it's actually based on a Far Side cartoon by Gary Larson. But it flies beautifully. The man who designed it has been designing rockets for a long time, and this is one of his more popular rockets.
Okay, and next we'll take a look at motors and talk a little about that. Okay.
Yeah. So the motor that would power the rockets in the previous two slides and this demonstration one I have here are loaded with black powder for the propellant. They are produced by the Estes company in Colorado, and it's a cardboard tube, a wound cardboard tube with an ejection charge, a clay cap pressed into the top of it, a black powder ejection charge, another type of delay charge that creates smoke so you can track the rocket as it goes through the sky. Then the black powder propellant, and a clay nozzle to provide the proper shape of the gases coming out to thrust the engine and rocket into the sky.
So it's the black powder that provides the energy?
For most of the low power and mid power rockets, yeah, it's a black powder composition that Estes, has their own formula, of course. There's another company in the U.S. called Quest, which is part of the Aerotech company, that also produces the 18 millimeter diameter motors that would work in these rockets.
Okay. Let's talk a little bit about the launch, rules for the launch. Mm-hmm. And I know that we've talked a couple of times, you've always emphasized the importance of safety.
Correct.
So tell us a little bit about that.
Yeah. The main thing that I like to maintain. We, of course, all want to have fun at these rocket launches. We want to watch other people fly their rockets. We want to fly ours, but mostly we want everybody to go home safely. So safety is a real large concern. The National Association of Rocketry has a safety code that we abide by, and part of that is, for example, the motors. We can only fly motors that are certified by the NAR organization. Another U.S. organization is called EEE, and there's a Canadian organization. The three of us do all the motor certifications for North America, and if EEE certifies a motor, NAR accepts it as certified. We cross-pollinate that way. So,
what about, it really surprised me, but it shouldn't have, but that the rockets can go so high that you have to get FAA approval sometimes?
Yeah, when you move away from the model rocketry, when you get into the high power rocketry, then we have to involve the Federal Aviation Association. We file paperwork with them every year to get a waiver to fly in a certain area, our general launch area, to a certain altitude, and that varies from club to club. For the low power, you don't need any of that, but when you get into high power, you do have to make sure that you're not going to be interfering with any aircraft that might be flying in the area.
So is it possible for a rocket to hit a plane?
It's possible. It's very unlikely, because we, as part of our safety code, we make sure there's no planes approaching us in the area. The paperwork that we file is supposed to generate notice to airmen, a NOTAM it's called. Pilots are supposed to read the NOTAMs for the area they'll be flying through, and when they're told to avoid a 1 mile radius around this point up to 3,900 or 5,000 feet, they're supposed to stay out of that cylinder of air. Many times they do, sometimes they don't. So we keep an eye out. We can hear airplanes, we can see them coming. When we know they're coming, we hold up our launch. The problem comes in with the high power rockets. They go up, we can control the time that it goes up, but we can't control how long it takes for it to come back down.
Oh.
And if it takes a few minutes for it to come down, a plane could come through the area, and that can result in some real problems.
Okay. Let's we're going to see a wonderful video clip in a moment, but let's take a look at a few other kinds of rockets that are launched. I found it fascinating. So if we can go to the Saturn one, the next. Oh no, that I think there's one. Is there one before that?
I believe the Saturn V is before this.
Can you go back one, please, for the slide? If not, let's talk about this then. So this is a saucer?
This is a saucer, and you can see the flames at the bottom of it are shooting out at different angles.
No, there we go.
Okay, there we go. Yeah. Okay, so this is a model of the Saturn V, the rocket that was used in the Apollo missions to put our astronauts on the moon and bring them back safely.
Is that using the little blasting powder?
This particular rocket is probably using a composite motor instead of black powder. It's ammonium perchlorate, the same material that was used in the solid rocket boosters of the space shuttle.
Wow.
Just a much smaller portion of it. But it has about twice the energy density of black powder, so it can give larger, heavier rockets a better boost off of the pad.
Okay, next slide, please.
Now this saucer, as I said, you can see the flames are coming out at angles. There's actually 5 motors mounted on this saucer, and they're canted at a fairly good angle, 35, 40 degrees. So this rocket actually spins around as it lifts vertically off the pad.
Like a flying saucer.
Yeah, it doesn't fly very high, but it's a very, very good crowd pleaser.
Okay, next slide, please.
This is a glider, what's called a boost glider. It has a motor on it that will push it off the pad at slightly more angle than we normally do, but the flyer has a remote control box, and he can control the flight of the rocket after the glider after the rocket motor has burned out. The rocket motor just boosts it into the sky, and then he can remote control glide it around.
Okay. And the next one, we talked about like a drag racing kind of a thing?
Yeah.
So what's going on here?
So this is a drag race that we hold at our annual Flisskits anniversary launch, and he's designed another rocket that is a 2-stage flying saucer. So we try to fill up all 11 pads that we have with these saucers, and they go up. The first stage might go up to about 75 feet, maybe 100 feet, and then the second stage ignites, breaks away from the first, and you have as many as 22 little things flying around up in the sky. It's very entertaining, and all done very safely, of course.
Oh yeah, yeah. And then we have one more, which is the really cool, I think, the multi-rock. Oh.
Now this is another what we call an odd rock. It's got the 3 fins. It's essentially got a nose cone, but the body is made up of coffee cups that are glued together. There is a cardboard tube going up through the center that holds the engine, holds the parachute for the ejection. But it's just another interesting little thing. You can make rockets out of all kinds of materials.
Yeah, yeah, very creative. Okay, let's come back, and we're going to show about a 5-minute DVD of a couple of things. Why don't you set it up for us? And we'll hear your voice, and then you're also going to do talk a little bit over it,
sure,
and explain some things. So, but what are we going to be seeing?
Okay, this is a rocket by a fellow in our club who's very creative with clustering engines together, firing more than one engine to lift the rocket off. So this rocket has a composite motor at its core, a number of black powder motors to help boost it, also give it a nice visual effect of a lot of smoke and a lot of noise. And it also has around the periphery of its fins, there's a ring there that has 6 other rockets mounted on the ring that will ignite sometime after the rocket has lifted off the pad.
Okay, wow. Well, when I first saw it, I was really kind of blown away. It's just very, very cool. So our wonderful director, Larry, when you're ready, let's roll the DVD. Okay, here we are.
This you can see, this was a quadcopter flight in toward the launch area, and that's of an aerial view with a couple of different rockets going up, and that gives you kind of an overview of the setup that we have out in a hayfield, recently hayed hayfield.
Okay, folks, you may not have known it when you woke up this morning, but this
Nitro
was the
Fireball.
rocket you came here to see. This is Boris Katan's Nitro Fireball. Get comfortable, I'm going to read a lot here. Stage 1, a G68 plus 6 SDZ-16s plus 16 SDC-11 zeros. Stage 2, 6 times rockets each with, each of them has a C-11-5 in them, so they're in the periphery, they'll go off on their own after a little bit. It's got a perfect flight altimeter on it, 7-foot parachute. So, high power pad B, a lot of stuff going up, a lot of stuff coming down. Going in 5, 4, 3, 2, 1, lift off.
And where are we going to be? Okay, there we go. Did they ever hit each other?
That's excellent for us.
That's a big parachute.
Big round of applause.
So does each rocket have its own parachute?
Yeah,
Okay.
especially the big one. Oh, that's really
4, 5, 6, they're all coming.
See up there? There's 6. Oh, yeah.
And a 7-foot
About how long would it
parachute's gonna
take
hold that
for
up there very
to
nicely,
land?
let it drift right over
Depends
to us,
on
so heads
how
up.
high it went, how low
Big
the
rocket
parachute
coming
is.
in, seemingly right at us.
A typical recovery speed is between 15 and 20 feet per second. There's still narration going on in the video.
Big round of applause. And now the other 6.
And as quite a courtesy to the flyer, that rocket came back very close to the area that we set up here. You can see on the right-hand side, notice that metal rail. That's the launch rail that guides the rocket for the first few feet until the fins can take over aerodynamically. Now this footage is shot from a camera that was taped to the side of the rocket on the top section of it, pointing down as it launched, but now pointing up as it's recovering. So we can see the large 7-foot parachute, bringing it gently back down to the ground.
Wow, it is gentle, isn't it?
Yeah. And then I think we'll see that again in slow motion.
Electronic station. Try to do. Thank you.
And again, you can see the rail on the right-hand side and how it guides the rocket until the rocket's fast enough. Now this is very clear. You can see the smaller rockets that will be fired off. They were actually fired by a booster engine mounted in the ring of the main rocket. As the booster engine burns through, it ignites the second stage motor, which was those 6 individual rockets. And if I'm not talking too much, you can possibly hear the clattering of the recovery system as the rocket falls back to Earth. In this case, the camera was mounted on the lower section of the rocket, pointed backwards, so now we're seeing the rocket as it descends to the ground.
It looks like a lot of fun. So at a typical launch, like how many people attend? How long of a day is it? I mean, how many launches are there?
It varies from club to club. My club, CMAS, Central Massachusetts Aerospace Modeling Society, is a rather large club, one of the largest in the national organization. It's not unusual for us to have as many as 75, 100 people flying rockets in a day.
Well, by the way, there's information about
the
national organization.
That's the National Association.
Which you're part of.
Which we're part of. We're a section of that. And if you want to see if there's a section that's close to you, you can go to the nar.org website, and they have Find a Local Club. If you happen to be in the New England, Massachusetts area, you can go to the cmas.org and see what our schedule is and come watch us, fly with us. We love to have spectators. But we typically put up 250 to 300 rockets in a period between 10 o'clock in the morning, 4 o'clock in the afternoon.
Wow. Okay, so I'm going to start out. So I go to the hobby store.
Yep.
And I pick this up, and I'm going to get the motor right. And
you're going to buy a package of motors that are
what would that
pre-made.
Cost me to? And people always wonder, is it an expensive hobby or not?
Right. Well, I always encourage people to utilize their local hobby shops if they have any left. Otherwise, there's places like Hobby Lobby, Walmart, even some Michael's arts and crafts stores have kits, and you can get a starter kit for around $30 that will have a little launch pad and a rocket or two. Another package of motors might cost $10 for three motors, but it's a good way to get started. But if you have a local club around, you can just buy the rocket, buy the motors, go out with them, and they'll have the ground support equipment to make your flying a lot easier, and you get to see a lot more of other people's rockets go up.
Okay, I imagine people are very friendly and very accepting and willing to help.
People are people. By and large, Rocketeers are very willing, though, to help somebody who's new and comes along to see what's going on, learn how to do things, how to progress in the hobby.
Okay, and what's the greatest launch you've ever seen?
Boy.
Let's finish with that.
Well, that Nitro Fireball that we had the video of was definitely spectacular. That fellow's also done a rocket that has 30 motors that ignite all at once. Very futuristic looking design. He's got a two-stage rocket that burns 51 little black powder motors in the two stages. A lot of smoke, a very cool sound.
But obviously, when he did this, he'd have to get it cleared, or in terms of safety.
Yeah. Oh, absolutely. Everything goes through the safety check, and he didn't start off with a 51 motor rocket. He started off with smaller clusters, and we got to know what he could do. He got to know better what he could do, and yeah, we do keep it safe, but we do have fun.
Well, you brought a lot of fun to the show, and we've learned a lot. Kenn Blade, thank you so much for coming here and sharing your knowledge and your enthusiasm for model rocketry. I hope you have learned as much as I have about the hobby, and maybe you would want to pursue it and go to that website and find a club nearby. This is Ron Levitsky for What's This Show For, FOR, Friends of Ron, saying we'll see you next time, and thanks for joining us. So,
thanks, Ron.